Hello, welcome back to Learn Physics. In today's topic, we are continuing with our current electricity chapter. So last class we learned about the Kirchhoff's laws, right? And about Kirchhoff's laws, we did some, I just told you some numericals, but I didn't do anything, okay? So first we will do that numericals now. Okay, so using Kirchhoff's laws in the electrical network, calculate the value of I1, I2 and I3. For that, the diagram is given like, here it is positive, negative, and here it is again one more resistance, and here another resistance and one cell. Here it is given as A, B, C, D, E and F. This is 5 ohm, this is 12 volt, this is 2 ohm, this is 6 volt and this is 3 ohm. Okay, clear? So here this is I1 and here it is I3 and here it is moving outside, it is I2. Okay, so calculate the value of I1, I2 and I3. For that, first we are considering three loops, closed loop, Kirchhoff's second law, that is second rule, that is loop rule we are applying here. Okay, for that first I am considering the loop A, B, E, F, A. Okay, in that what I told yesterday, if we are moving, if the loop is moving along the direction of current, then the potential difference across the resistance will be negative, and if we are, while moving in the loop, first we are observing the negative terminal, we will write it as positive. Okay, clear? Now write down, we are starting from here, AB, no resistance, BE, there resistance is there, so potential drop is there. What is the potential drop? I3 into 2 ohm. IR. We are moving along the direction of current, right? So it is negative plus or minus, we don't know. Next is EF and next is FA. In FA, first we can see one cell. Negative terminal, we are observing the negative terminal first, right? A, B, E, F. In that F is negative. So first we are observing the negative, so we can write it as positive. Plus 12, and this I1 is moving along the direction of current, so I can take it as negative I1 into 5, that is equal to 0. Then next one, B, C, D, E. Here B, C, D. So here in CD term, CD that side, you can see we are moving from C to D, but the current is moving towards C. Right, so it is moving in the, our meshes or loop is moving in opposite direction of the current. So we can take it as positive I2 into 3. We are observing the positive terminal, so we can write it as negative minus 6 B, C, D, E and B also. Okay, we are reaching to the final E, then B. So here also we are moving opposite to the direction of current. So it is positive plus I3 into 2, that is equal to 0. Next I am considering the other loop A, B, C, D, E, F, A, this loop. So A, C, D, F, A, this big loop I am considering. So AC, here no cell or no resistance. Right, then next we are considering the loop CD. While considering CD, you just see we are moving opposite to the direction of current, so it is positive plus I2 into 3. First observing the positive terminal, so minus, then we can observe the negative terminal, so it is positive plus 12 and I1 same direction of current, so I1 into 5 is equal to 0. Now we are arranging each one. So this one we can arrange it as I1, 5I1 minus 5I1 minus 2I3 equals minus 12. That is 5I1 plus 2I3 equals 12. Clear? Like that we got. And this is, I am writing it as equation number 1, and here it is 3i2 plus 2i3 equals 6. So here in this one, 3i2 minus 5i1 equals, so here plus 6 is coming. So here plus 6, while we are taking it to the other side, we will get minus 6. So we are getting the 3 equation, and 1 we should solve. Equations, now we got these 3 equations, right? So, and one more equation I am writing, so it is for the easiness. So from here also current is coming I1, and here also current is coming I2. So if I am taking this point B, at the point B, if I am applying Kirchhoff's law, see, it is current is coming from I1 and I2, and it is going from I3, right, is equal to 0. So I will get it as I1 plus I2 equals I3. So this one, another equation I am getting over here, right, equation number 4. Now I can substitute for I3 these 2 equations. Okay, so 5i1 plus 2 into I1 plus 2i2, that is equal to 12. Right, so 7i1 plus 2i2 equals 12. Clear? And then here, while we are substituting for I3, I will get 3i2. This is equation 1 became like this. Now equation 2 I am changing. Okay, 3i2 I am writing it as such. 3i2 plus 2i1 plus 2i2 equals 6. So now I am getting it as 2i1 plus 5i2 equals 6. Equation number 5. This is equation number 6. Clear? This I3 equals I1 plus I2. I am substituting in these 2 equations. And we got here, see, one equation and the other equation. Both the equation we can convert it in the same manner. How we can? I am multiplying 2 into equation 5, which will give you 14i1 plus 4i2 equals 24, and I can multiply 7 with I1. 7 with equation number 6, so I will get it as 14i1 plus 35i2 equals what is that? 42. Clear? So while subtracting these 2 equations, I1 will become equal to 0, and I2 I will get it as 31i1, sorry, this is I2, 31i2 equals 18. So I2 I am getting it as 18 divided by 31. So this is the mathematical calculation. In the same manner I can find out. If I am substituting any one in over here, this equation 6. In equation 6 you can convert it as 2i1 plus 5 into 18 divided by 31, that is equal to 6. Okay, so 2i1 equals 6 minus 31. Okay, so 31 I can solve it as 186 minus 90 divided by 31. So the answer will be 96 divided by 31, 2i1. Okay, I1 I will get it as 48 divided by 31. This will be I1 value. Okay. Now we can do it for this. Now I1 we got and I2 we got. We can find out I3. How we can find out I3? I3 will be equal to I1 plus I2. I1 is 48 divided by 31 plus 18 divided by 31. So we'll get it as 66 divided by 31, that is I1. So here first you need to get any 3 equations. While you are getting the equations, it will be easy after that. Okay, clear? So some lengthy calculation is there, but then also if you understand this concept, that is Kirchhoff's law, you can easily do that. Clear? So the next one, two cells of EMF 1.5 volt and 2 volt, internal resistances 1 ohm and 2 ohm are connected in parallel so as to send current in the same direction through an external resistance of 5 ohm. Draw the circuit diagram using Kirchhoff's rules. Calculate the current through each branch of the circuit. Potential difference across 5 ohm resistance. So yesterday I drew the circuit diagram and we didn't find out the current. So current in the same way only we should find out today whatever we did. Okay, and potential difference across 5 ohm resistance, that we will find out. Okay, so the diagram was here. So one positive, negative, and this one, and here it is another positive, negative, and this is another resistance, and here again 5 ohm. This is 5 ohm resistor, and this is A, B, C, and here it is D, E, and F. 1.5 volt. Here I1 is moving here, from here. Now here from I2, and here it is I1 plus I2, that is I3 you can write, or I1 plus I2 you can write down. And next is 1 ohm here, this is 2 ohm here. Okay, here passing through I1, this is I2. We need to find out the current. Okay, tell along with me, or you can pause the video and find out all the currents passing through I1 and I2 you should find out, and through this resistance 5 ohm how much will be the current. Okay, if you are getting the current you can easily find out the potential difference, right? So clear? Now tell me in A, B, E, F. We are starting from A, B, and E. First I am seeing the positive terminal, so it is negative. The value of voltage over there is 2 volt. 2 volt. So minus 2, here I am considering, yes, it is opposite direction, so it is positive. I2 into 2. Right. Next is here. Same direction, so negative. I1 into 1. Seeing the negative terminal first, so it will be positive plus 1.5, which is equal to 0. Okay, so for better understanding, if you didn't watch yesterday's video, please watch yesterday's video about Kirchhoff's law, and after that you can continue over here. Okay, so this one, while then next one I am considering the next this one circuit, that is BEDC. Right, so in BEDC, B, first I am observing that positive terminal, so it is minus 2, moving opposite to the current, that is 2I2. Then here, what is the current moving opposite to the current? Our terminal is moving opposite, our mesh is moving opposite to the direction of current. Current is moving in this direction, right? But our loop is moving from D to C. So it is, I am considering it as positive, plus I1 plus I2 into 5 ohm. That is equal to 0. Clear? So we got these two equations. So here I can write it as minus 2 plus 1.5, that is 0.5, minus 0.5 plus 2I2 minus I1 equals 0, that is 2I2 minus I1 equals 0.5. This is equation number 1. Okay, this equation I can rearrange it as minus 2 plus 2I2 plus 5I1 plus 5I2, that is equal to 0. Now I can write it as first I will write down for I2, 7I2 plus 5I1 equals 2. Equation number 2. Right, now I can multiply 5 over here, 5 into equation number 1, 10I2 minus 5I1 equals 2.5. This is equation number 3. Now subtracting these two, so adding these two equations, I will get 17I2 equals 4.5. So I2 equals 4.5 divided by 17. Okay, this much of ampere. Clear? Then how much will be I1? I can substitute in any one of these equations. I can substitute. So here I am substituting in equation 1. I will get 2 into 4.5 divided by 17 minus I1 equals 0.5. So I1 equals 9 by 17 minus 0.5. I can write it as 5 by 10. So here, while calculating, how much you will get? 90 minus 85. So we will get it as 5 by 170. So here we will get it as 1 by 34 amps. So I1 I got it as 1 by 34 amps and I2 I got it as 4.5 divided by 17 ampere. So this one how much will be the current passing through 5 ohm? That is I1 plus I2. Therefore I1 plus I2 equals, what is that? 4.5 divided by 17 plus 1 by 34. So I can write it as 34 is the LCM and here you will get it as 9 plus 1, 10 by 34. This much of ampere current will be passing through each this 5 ohm resistor. So potential difference will be equal to 10 by 34. V equals I into R. Okay, so 50 divided by 34 volt. Okay, clear? So this is how we will be finding out. So this kind of questions are actually easy questions but little bit time consuming, or say if you know the calculation, if you know to do the calculations faster, you can do it easily. Okay, so the next one is use Kirchhoff's rules to determine the potential difference between the points A and D when no current flows in the arm BE of the network as shown in the figure. So here in this diagram, this is the diagram. Here no current is flowing through EB. That means, so here positive from here like this. So this is how it is moving and coming here it is positive to negative. Here it is negative. It's coming here. Okay, so this is how it is. The current is moving in this manner. We need to find out the potential difference across AD. Okay, if we need to find out the potential difference across AD, here no current, right? If this is not there, this is in, all these are in series circuit. So same current will be flowing through all the other points. So I is the current flowing. Okay, now I can find out this potential difference between AD. So between AD, this diagram I am considering. Why I am not taking this side? Because here R value is not given. Okay, here all the values are given, so I am considering that loop. Here this is not required because no current is flowing through that. So this is A, this is the point A. From A, this is 2 ohm, negative, positive, 1 volt, and next is 3 ohm, and next is D. Okay, this is the terminal, and this is 2 ohm. Clear? Now I am considering current is moving in which direction? From positive to negative. So here current is coming here, from here outside I. So I am taking the direction of current. So from here VA, now here it is higher potential to lower potential. So minus I into 2, here it is lower to higher potential. So it is plus 1, here higher to lower potential. So minus I into 3 will be equal to VD. So what is VA minus VD? VA minus VD equals 2I plus 3I minus 1. Right? So 2I plus 3I, we will get it as 5I minus 1. Okay, so we require the value of I. For that, first I can consider this closed circuit. So if I am considering this closed circuit, here R value is not given, right? So I am not taking this circuit, I will take this circuit. Okay, in here, taking the circuit from where I will start A, F, E, B, A. This circuit I will consider. Okay, here current is moving in the direction of resistance, right? If current is moving in the direction of resistance, I will take it as negative minus I into 2. First observing the negative terminal, so it is positive plus 1 minus I into 3 minus, here current is not flowing through R1, right? So not required. Next is minus negative terminals I am observing first, so I am taking it as positive. Next again positive, that is equal to 0. Okay, so here I am not considering the value of R1. Why I am not considering the value of R1? Because no current is flowing through the circuit. So I value is equal to 0. So I into R1, 0 into R1 is equal to 0. So here I will get it as minus 2I plus 1 minus 3I plus 9 is equal to 0. So I'll get it as minus 5I plus 10 equals 0. So we will get it as 2. I is equal to 2 ampere. So VA minus VD will be equal to 5 into 2 minus 1. So 10 minus 1 equals 9 volt. Okay, clear? So this is how we will be finding out the voltage value. So this is a previous year question. So such kind of questions you can try. And so today was a fully numerical part, that is problem solving. How we will be doing for the Kirchhoff's law I was explaining. So I think it is clear for you. And here and all you should remember only one thing. If we are moving in the direction of current, if the loop is moving in the same direction of current, what we should do? In the case of resistors, we will take it as negative. If we are moving opposite to the direction of current, then we will take the potential as positive. And here first observing the negative terminal means that will be a plus value, and if we are first observing the positive terminal, we will give a negative line. Okay, clear? Understood? So I think it is useful for you, and if you like the channel, don't forget to subscribe, like and share. Thank you for watching. Bye.